Okay, so this is a really cool lab actually that can kind of show you practical ways to implement position versus time and velocity versus time. This is our first introduction into a velocity versus time graph. So remember how we were calculating all those different slopes? Well, we can actually graph those slopes and all those different problems on a velocity versus time graph. So if we're looking here, you don't always have to start at position equals 0, so I kind of start at -10 to change it up. I'm going to give myself a velocity of 2 meters per second, okay? And now I'm going to go ahead and press play. So notice how he is moving at 2 meters per second, right? After 2 seconds, he travels past this -6. And if you look down here at the graph, you can see at 2 meters per second is just a straight line. Now, what will happen is if I change this all of a sudden, let's do -2, all of a sudden, the graph here changes and the position versus time graph changes as well. Because there's an abrupt change in slope, all of a sudden, the slope changes and we move and move and move at a constant -2 meters per second velocity. And now down here, our velocity all of a sudden stayed from 2 changing to -2. And I'm pausing the video right now just because it's going to keep going and then we'll lose it on the graph, right? But you notice how at this position versus time, I'm not moving anymore? All of a sudden, the velocity versus time graph moved to 0 as well to represent that there is no movement changing. Okay? That's really all I want to show you with this video for now, but we will come back and use this program multiple times. I just kind of want to use it to show you what velocity versus time looks like, and you know how it corresponds right here. So at this region from 0 seconds to about, where did I stop? 6 seconds. We have the exact same slope corresponding to the slope here is the velocity here. All of a sudden it changes, and from this region of time, they correspond, where the slope here gives us the value of our velocity versus time graph here. And then at this point, it corresponds from between these graphs. That's going to be the trickiest thing, is that these types of graphs are very interrelated, and none of them happen in a vacuum. None of them happen separate from one another. Okay? Last thing before I go on is that I forgot.